So today's going to be kind of a fun one because what we're going to do is we're going to go through and we're going to work with some firewall rules. So I gave some prep to go through and do if you wanted to be able to follow along with the hands-on examples that we do here. So feel free to kind of run through these steps real quick if you haven't already. I'm doing this on an Ubuntu, I think it's probably 24 LTS system. That's pretty common. And it's just a server stripped down. You don't need a whole lot of software beyond what I got listed here. IPTables should already be installed unless you did a minimal Ubuntu install, in which case, that might be missing. But you should be in pretty good shape. And then once you're done, you should see something like this. So you should be able to see a list of files that get created in an FW firewall directory. And I'll go hands-on and we'll kind of poke through these scripts and what they are in just a second. So this Fireside today is going to completely build on what we did last week. So I'm not going to take the time to talk about, we're going to create a static filtered firewall. We're going to create a stateful filter firewall. And I'm not going to bother taking the time to describe what the differences between those is supposed to be because we talked about all of that last week. So if you go through this week and you're kind of confused by some of it, that's okay. Go back to last week's Fireside Friday and that should be able to fill in the blanks for you. But like I said, I'm going to do this as a hands-on walkthrough. So what we're going to do is we're going to cheat a little bit, and we're going to use a single Linux system. So normally, as I'm sure most folks know, a firewall, it gets installed inline, meaning it has one interface that faces towards the internal network. It has another interface that faces towards the external network, and then it controls the traffic that's allowed to pass across it. We're going to cheat a little bit with that, and that we're going to use the loopback interface on our Linux system. So the traffic is going to go to and from the same system. That's okay. The firewall rules we create are going to be the same as what we may use if we were working with a true full-up firewall. The only real difference comes in where you apply those rules if you're using an IPTables firewall. IPTables uses 3 separate policies by default. You can create your own, but there's 3 different policies that you can use to define rules that get implemented in a certain way. So for example, there's a policy called the input chain. And what that does is that controls traffic going to the firewall itself. There's an output chain, which controls what traffic is allowed to leave the firewall itself. And there's a forward chain, which is used to interact with, you guessed it, traffic that's getting forwarded across that firewall. So it'll be traffic that's coming in one interface and trying to go back out another. So in a real firewall, we would probably be doing most of these rules within the forward chain. But since we're only working with a single system, we're going to be working with that input and that output chain, specifically mostly the input chain. So we're going to be controlling what traffic the firewall can send itself over the loopback interface. And we're going to do this by setting up 3 different listeners. So let me get a couple of things spread out here just to make sure I've got everything going right here. All right, give me just a second. I have too many screens open at the same time and kind of lost track of a few things. Oh, okay, here's that one. Awesome. Cool, let's do this. So let's start with the special files I had you pull down. So that should have created an FW directory, short for firewall. And if we CD into that directory, what you're going to see is a bunch of scripts. And each of these scripts has a different role it's going to play in the testing we're doing. So you could type all this stuff out manually if you wanted to, but I just always find it a little bit easier to go through and automate things with scripts as much as possible. So remember we said we're going to set up a bunch of listening ports. So let's take a look at what those are going to be. And we'll actually create those listening ports using this script called listen. So if we look at the contents of it, it's using netcat, or NCAT for short with this particular binary, to go through and create these listening ports. Now, the first thing we do is we say, hey, if netcat is already running on the system, kill it. And what that does is that avoids any conflicts like, hey, port 12345 is already open and now you're trying to open it again. I don't know what to do. Well, by killing any instances of netcat, that's going to take care of that. Then what we do is we're setting up 2 TCP listening ports, port 1234 and port 1235. So all this is going to do is it's going to hold open that socket, 1234 and 1235, so that if anything tries to connect to that port's going to be an open port because there's an application sitting behind it, specifically NCAT, and now that'll accept any data that tries to come in through those ports. These commands here are opening up UDP 1234 and 1235. So it's gonna. So we're setting up two TCP, two UDP ports in order to go through and kind of. What this is going to do is it's going to allow us to set up. We're going to look for three conditions. We want an open port and a closed port. We're going to try different scans against them. And then what we're going to do is try different scans against them, but with the firewall rule in the way, trying to control traffic to keep it from actually getting to that port. And we're going to see what happens as part of that. So that's the listen command. The one that goes with it is kill listen. And if we take a look at what's in that file, all this does is this goes out and it looks at, actually I could have just done a pkill net NCAT on this if I wanted to. But yeah, this just goes through and it looks to see, hey, is NetCat running? If it is, go through and kill it. And it just echoes some information to the screen to tell you what it's actually doing as it does it. Pretty straightforward. The other tool we're going to be using is the scan tool. So the scan script, actually, let me clear the screen first. So the scan script, I'm using hping3, or hping for short, to go through and create and craft my own packets that I want to use as part of this probe. So what we're doing here is we're creating 3 TCP packets going to ports 1234, 1235, and 1236. We're turning the SYN flag on, leaving all the others off, and we're only going to send one packet. So the idea will be when this packet hits that port, what type of reaction comes back to the whole thing. Then what we're going to do is we're going to go through and we're going to run three scan packets again against each of these ports. But this time we're only going to turn on the FIN flag. So we mentioned this when we were talking about IP and TCP in general. This should never happen in the real world. You'll never see you should never see a packet with just FIN turned on by itself. What you'd see is the FIN flag and the acknowledgement flag turned on. So these shouldn't exist. So different operating systems handle them slightly different ways. So we're going to take a look at that. And then finally, we do similar where we go through and we do a UDP port scan. One other thing with the listen. So the UDP ports, there's a known bug with using NCAT, which is when something connects to those ports and then disconnects, that port actually closes. So one of the things we'll have to do with our UDP scan is scan those UDP ports, and then we're going to have to restart NCAT again. But that's not a big deal. We've got scripts to do it, so it makes it a whole lot easier. So we've got a script to set up our listening ports. We have a script to kill them if we need to. We have a script to go through and do our port scans. The rest of the scripts revolve around managing the firewall itself. So for example, there's a FW rules one, and all this does is print out the firewall rules. So if I run that, so I'm going to say period / because it's not a script that's in my path, it's in the current directory. And I'm just going to say FW rules. And when it runs that command, notice what it comes back with. It says the default policy for input is to accept traffic. And then there's no rules in here to tell it to do anything interesting with the traffic. So in other words, there's no rule saying let this through, let that through, or deny this or deny that. There's nothing like that. So the policy is empty. So this policy it's talking about here, this is the default at the end. So what will happen is, let's say the firewall sees a packet and it's coming into the firewall itself. It's going to go to the input chain and it's going to say, okay, let me go through all of the rules to see if any of them match this packet I see. And if none of them match this packet, I'm going to fall back on this default policy to decide how to handle it. That's basically how to go through and read this. And this will be a little bit more interesting once we actually have some rules that are, or once we have some firewall rules built in there. Okay, so that's the clear one. We also have a couple of rules for, or a couple of scripts for going in and creating our rules. Now, if we want to clear them, we have FW clear. So all FW clear does, actually, let me show you the contents of this, is it just goes in and it says, hey, change the default policy. So actually, I threw the forward chain in here. I didn't really need to, but make sure the default policy is set to accept. And then this says flush any existing rules that are currently in the input chain. And this says flush any rules that are in the output chain. And then this says, okay, now print what rules are there, and there should be none. So this is how, if we need to get back to a non-firewall state, we just run the FW clear. That clears all the rules. Bang, we're off to the races again, and everything's in pretty good shape. All right, now let's take a look at our scripts that are going to actually create our firewall rules. So the first one we're going to take a look at is I think it's FW static. Yes, FW static. So here's what this one's going to do. The first thing it's going to do is it's going to set the output chain to be accept, meaning the firewall, the system itself, can send any traffic it needs to, and there's going to be no restrictions on that. Then what I did is I said, hey, just in case you're running this on a cloud instance and you want to be able to keep your SSH session to this box running, let's create an exception for SSH. Because without that rule, if you run one of these firewall scripts, it would kill your access to that server. And there's nothing worse than having a remote cloud server you can't get remote access to anymore. Then what it does is it goes in and it creates these two rules here. So this one says, hey, anything coming to the firewall itself that's based on TCP in this line or UDP in this line, port 1234, accept it. So remember, 1234 and 1235 are set up to be listening. So we're only telling the firewall, let traffic go to port 1234. The firewall is going to try and reject any traffic going to port 1235, and we're going to get to see how good does it do at that. What am I running? Yep, Bill is exactly right, Ubuntu 24 LTS. So that's what I'm running here. This should be fairly easy to adopt for any platform, though. These are not complicated scripts by any stretch of the imagination. So I'm letting in traffic to the TCP and the UDP port 1234, and that's it. Then what I'm doing is I'm creating a rule that says, hey, anything that looks like a reply coming back to the firewall, I want you to go through and permit that through. I want to accept that. Okay, what's our criteria to figure out if it's a reply or not? Well, this is a static filter, so there's no concept of state. So the only thing I can look for is the SYN flag is not turned on by itself. And if that's the case, then this is probably a reply, because the only time SYN is turned on by itself is at the start of a session. So we'll go through and we'll deal with it that way. Then what we're doing is we're saying, well, actually, we got to kind of let our replies back in for any UDP traffic. And UDP, the reply port is going to be anywhere from 102.24 to 65535. So we're going to be able to let that stuff through too. And then we go through and we say, okay, now our default, we're going to change our default policy so that if it doesn't match any of these here, I want to go through and I want to drop that traffic. And then I go through and I just print out what the rules are. So that's our FW static switch or script. That's what that goes through and does for us. Now the complement to that is FW no, I didn't call it stateful. I think inspect, because I'm actually going to go through and inspect these as they go by. So this is our stateful firewall that we're going to create. Kind of similar to the last one, where we go in and we say, flush any existing rules. That way we're not duplicating any potential rules that are in there. Then we're saying, hey, anything trying to leave the system, if it's part of what this says is create a state table. And if this is a new or established session, let it through. So what's going to happen when this rule gets hit is when this rule gets hit, the firewall is going to say, that packet that I'm trying to figure out what to do with, let me see if it matches any of my state table entries. And if it's part of a previously established session, or if it's a new entry that doesn't exist in the state table yet, this is okay. Go ahead and let it through. And if it's new, I'm going to write a state table entry to record that this traffic was let by. Here's my rule to make sure we don't lose SSH traffic going to the system. And then here are kind of our primary firewall rules here. So we're going in and we're saying, hey, any TCP traffic going to port 1234. So again, this is the port we're trying to open with the firewall. Port 1235 is a listening port, but we're going to try and block it with the firewall. And this, similar to that first entry, says go reference that state table. And if this is new or part of an established session, go ahead and let it through. Then I go in and I say, I'm going to let my replies through. If it's based on TCP, UDP, or ICMP replies, go ahead and let it through. Actually, now that I'm looking at it, I messed up this one a little bit. Because with ICMP, one of the possible states that I didn't list here is related. So that should say established, comma, space, related. I've missed that part of it, but for the purposes of the testing we're doing, that shouldn't cause us any problems at all. And then again, it goes through and it kind of prints everything out. Cool. So that should be all of our scripts. Yes, that is all of our scripts. Awesome. So what I'm going to do is in this window here, this is where I'm going to go through and I'm going to set up my listening ports. I'm going to open up a second window here. And this window is going to be for running my scans to see what's going on. And now I'm going to open up a third window. And this one, I'm going to run TCP dump so I can watch the packets as they go by. So I'm going to say TCP dump space dash NN, don't resolve IPs, don't resolve ports. And then I'm going to say dash I, this is the interface I want to listen on. And I'm going to say the loopback interface, which is LO for short. Now I could say dash capital X if I wanted a complete decode, dash VVV if I wanted more verbose details, but quite honestly, we don't need it. This command here should be fine. So I'm going to go ahead and open. It's saying, hey, you don't have permission to do that. So I've got to run that with sudo. And now that I ran it with sudo, it's saying, hey, I'm here and I'm listening. This is running in the background. Everything should be set to go. Awesome. So step one is done. We've gone through and we've set up our packet sniffer to see these packets as they go back and forth. All right. Now what I'm going to do is I'm going to run my scan. So we're going to try running a scan without any firewall in place at all to go through and see what it comes back with. So here's the results from the TCP scan, because I have the script set up to pause when it gets through each portion of the scan. And notice when it tried to hit port 1234, nothing came back. Reset ACK, reset ACK, reset ACK. Oh, wait, that's right. Before I do the scan, I'm going to kill this script. Before I do the scan, I actually have to set up my listening ports. I didn't do that when I was in my first window here. So to set up my listening ports, I'm going to run the listen script. And when I run that, notice it came back and said, okay, I launched 4 instances of NCAT. One of them is listening on TCP port 1234. One is listening on TCP port 1235. I'm also opened up UDP 1234 and UDP 1235. Notice just the way Linux decides to print things out, it only lists the TCP ports as listen. Technically, the UDP ports are listening as well. It just doesn't give it that nomenclature because it's a non-stateful protocol. Okay, so now that we have our listening ports open, now let's go back and run our scan. So again, we're scanning opened and closed ports with no firewall in the way. So let's see what this comes back with. So with our SYN scan, anytime it hit an open port, right? We said 1234, NCAT's listening and holding that open. It's returning a SYN ACK. Okay, same thing here. Port 1235, that's the other one we opened, SYN ACK. Now port 1236, we don't have a listener on. We didn't set up NCAT to listen on that port. So when we're hitting a closed port, it gets back a reset ACK. So that kind of tells us with a SYN scan, if I get back a SYN ACK, that's an open port. If I get back a reset ACK, that port's closed. Pretty straightforward. All right, now I'm going to go through and run the rest of my scan. The UDP one takes a little bit longer. Now notice with my UDP scan, I sent oh, actually, I'm sorry. Wasn't a UDP scan. This is the fin scan. So I'm doing a fin scan. So my fin scan went to an open port, and I didn't get anything back. And then my fin scan went to this closed port, and I got back a reset ACK. Well, nothing happened here. Am I sure? One of the reasons for running TCP in the background, or TCP dump in the background, is I can see what are the results of the scans I'm doing. So I can see right here, here's my scan going to port 1234, and notice there's no reply that comes back, right? There's no reply going back to port 1237. Here I did a scan against port 1235, and again, nothing came back. I see nothing getting returned to port 1922. Here's where I sent that SYN packet to a closed port. And notice when it went to a closed port, I sent the fin packet, but what came back to that port number was a reset ACK. So with my fin scan, nothing coming back on an open port, or a nothing coming back means it's an open port. Reset ACK coming back means it's a closed port. So again, we're going through and we're trying to see what are the different stimuluses, based on the stimulus we're sending, what's the response that comes back? So I'm going to put a little white space in here so it's a little bit easier to read. And now I'm going to go back here. And this time we're going to go through and we're going to run our UDP scan. And with our UDP scan, this came back and we got 2 scans that nothing came back. We have 1 scan where we got back a port unreachable. Okay, great. Let's go look at our TCP output here. So here we can see when we were talking to port UDP 1234, nothing came back. UDP 1235, nothing came back. So when a UDP port is in an open state, and I just connect to that port, or I send an empty packet to that port, it doesn't return anything. It doesn't know how to handle it. It doesn't know what to do with it. Now here, I sent a UDP packet to port 1236. That's the port we didn't open up. And notice what came back. What came back was an ICMP port unreachable. So the system responded when we sent a probe to a closed port saying, hey, that port's unreachable. There's nothing listening on that port. Hopefully this is making sense for folks. So we've done our TCP scan, we've done a SYN scan, a fin scan, and we've also scanned the UDP ports. We've seen the difference between when the port's open and when the port's closed, and how it responds differently to each. Cool. So now what I'm going to do is I'm going to go in and I'm going to run, so remember I said we've got a little bit of a problem in that the UDP ports are going to close themselves up. So what I'm going to do is I'm going to run the kill listener command to kill all my NCAT processes. And then I'm going to go in and I'm going to rerun listen just to make sure those UDP ports are in open state. So now I know for sure all my stuff is listening the way it wants to. Great. Now what we're going to do is we're going to create a set of static firewall rules. So this is our lowest end packet filtering firewall. Based on static filtering, although we said even in inspection, a stateful inspection firewall may rely on this technology to control traffic. And in fact, it may, a stateful inspection firewall, a lot of the ones I've looked at, will use this technology for more protocols, for more protocols. So we're talking about what value is recorded to byte 9 in the IP header. What protocol is running on top of it? Is it TCP, UDP, ICMP, GRE, ESP, whatever? It'll handle more protocols based on static packet filtering than it will actually implement stateful inspection for those. So we're talking about a low-end firewalling technology, but as I explained last week, vendors still use this, and it's still used quite frequently. So it's kind of good to know and kind of good to be able to figure out how to test how has your firewall vendor actually implemented this stuff. Okay, so we got those ports open and listening. Great. Now what we want to do is we want to go in and we want to create our firewall rules. So I'm going to go in and I'm going to run my FW static script. And when I run that, here's the rules it went through and set up. And I'm not going to run through these again. But as we said, we're opening up TCP and UDP port 1234, which means that 1235, which is an open port, is blocked by the firewall. And 1236, which is a closed port, is also blocked by the firewall. Great. So now let's see, did we get anything new? No, we didn't. So now let's go back and run our scan again and see what happens. So we're running our SYN scan, and it's coming back and it's saying, oh, hey, I got a SYN-ACK back on one from port 1234, but I didn't see anything as a response from the others. Well, if we go back to our packet sniffer, we can confirm that. Yep. So remember, we wanted to open port 1234 through our firewall, and we wanted to close everything else. So this is what we expect to see, right? We sent a SYN packet, we got back a SYN-ACK, and then our tool reset that and said, hey, no, close that port. I didn't mean it. I know I tried to talk to that port, but I didn't mean it. It was a butt dial, right? So it was a butt dial trying to talk to that port. I didn't really intend to. Reset, let's go ahead and just kill that session. So UDP 1234, from the perspective of the scanner, we can tell this port is open. Now, port 1235, though, that doesn't look any different from 1236, the closed port. We got nothing back. So with our static filter in place, if somebody runs a SYN scan against us, we can successfully block those and make sure that they can't tell if a port's open or not. What was the TCP command we're using for the listener? Cool, I will pull that back up, and in fact, I will just throw that into the Discord channel. Pretty straightforward. There you go. So, and again, all this command is doing is running TCP dump, -n, don't try and resolve IPs to host names, -n, don't try and resolve port numbers to well-known names. And then this says, I only want to listen on the loopback interface. So we have that up and running. We get some white space in there. Okay, so that was our static filter. Great. Now let's go in and let's run our let's do our next scan, which is a fin scan. So this time when it runs, it comes back and says, hey, we got back a reset ACK packet here, but we didn't get back another. All right, let's look at the trace to see what this is telling us. So we hit the known to be open port, and we got back a fin. All right, we got nothing back in response to our fin. Then we hit the port that's open, but it's being firewalled, and we got the same response we did when we hit an open port. Nothing came back. Then we sent a fin packet to the port that's closed, and we got back a reset ACK. In other words, these fin packets are actually making it through our firewall rules. Remember, we got a static filter, and static filters can only work with what's in the packet. So when I say only let back in replies, what I'm really saying is, hey, if SYN isn't set by itself, assume it's a reply and let it through. Well, when fin is turned on by itself, that is not a packet with SYN turned on by itself. So the firewall does actually pass it through. So in this case here, we're able to probe which ports are open and which ports are closed, even though we got a static filter firewall in place. So the static filter firewall works great against SYN scans, falls flat on its back when you're dealing with the fin scan. All right, let's get a little white space in there. And now we're going to go and we're going to run against UDP and see what happens. And it looks like we're not getting, oh, we did get one port unreachable back here. So let's see what we got. So port 1234, nothing came back. 1235, nothing came back. Right? And remember, both of these ports are open, but one of those is being permitted through the firewall. And then when we tried to hit 1236, we got back port unreachable. So we're actually seeing what's going on here. So the reason this stuff is getting through is, remember, I had to create a rule to let back in replies. Replies can be anything from port 10,024 all the way up to 65535. Well, this is port 1234 through 1236. That's within that range. So by trying to let UDP replies back in, inadvertently opening up access to these service ports at the same time. Now, if I had told the service, listen on port 80, okay, we won't have that problem because that's below that reply port range. So this is something that is an impact only when you're dealing with ports listening above 1024, which unfortunately there's a lot of them, that you're going to run into this type of thing. So here our static firewall was useless in being able to keep out this type of traffic. Let's see. Okay, just checking questions, seeing if I missed anything. Cool. All right, so that is our fin scan. That's our fin scan, excuse me, that was our UDP scan with our static packet filtering rules. So now what we want to do is we want to go in and we want to flush these static rules and we want to replace them with stateful rules. Excuse me. So so the first thing I'm going to do is I'm going to run the FW clear script. Well, actually, I'm going to try and I'm going to actually be typing in the correct window for this. So I'm going to run my FW clear script. And then when I do, that's going to wipe out all the firewall rules that are currently there. Then what I'm going to do is I'm going to run FW inspect. I want to set up inspection rules for this. Remember we talked about this? Hey, go in and use the state table and figure out if it's new or established. If so, it's okay. Remember we went through and we kind of talked through this whole thing already. I got kicked out from my RDP to my VM. Yeah, so I think as Bill is talking through, RDP was not one of the rules that we created, unfortunately. I set up SSH. I didn't expect anybody to be running RDP, so I apologize for that. So that's my fault. Now the nice thing about this is we're running these scripts manually. So if you're having trouble recovering, if you can't like SSH in and then clear the firewall rules that way, you can always just reboot this system. And because we ran these rules manually, they're not going to come back when the system gets rebooted. So you can go through and you can recover that way. But I apologize for that. Who was it who ran into that? Eric. I apologize for that. Actually, it was Juju. Sorry. Yeah, what Chris said. Cool. So now we have stateful firewall rules in place. Now I'm going to go back here and I'm going to kill my listener because remember, known UDP bug, it may kill that UDP port just because something tried to talk to it. So I'm going to go through, I'm going to kill all my listening, and then I'm going to go in and set up new ones. So here's my listening on TCP 1234, 1235, and UDP 1234 and 1235. Cool. I got some white space in here. So let's go back and run our scan and see what happens now that we have stateful inspection set up for this. We're handling our traffic in a stateful fashion. We're using state tables. Okay, this time it looks like all my scans came back. I got a SYNAC back from 1234, and it doesn't look like it was overly successful with the other ones. So let's go back and look at this again. Let's look at the decode of the packets. So here's my SYN packet going to 1234, and that got a SYNAC in return to that. And then we killed it saying, yeah, no, sorry, butt dial. We didn't really mean to try and connect to that port. But then we sent a SYN packet to the other open port and the closed port, and nothing came back from either of those. So this is the same results we got as the static filter. So static or stateful, both of them are effective against a SYN scan. All right, throw a little white space in here, go back to my scanning, and now I'm going to try a TCP fin scan and see what happens. So this time it doesn't look like a whole lot's coming back. So remember with the fin scan, with the static filter rules, I was able to hit open ports that we were trying to protect with the firewall. I was able to hit closed ports that again we were trying to protect with the firewall. Because we're using a state table now, though, none of these get through. Notice there's no difference in the response with an open port versus an open port that's being protected by the firewall versus an actual closed port. So these fin packets are no longer making it through. So with our static firewall, fin scans can blow right through it. With our stateful firewall, fin scans get controlled properly. Cool. All right, let me hit enter a couple of times. And now let's try our UDP port scan. So we'll go through and we'll run that. Now before we saw an ICMP unreachable come back, we're not seeing it here. So again, this is kind of similar to what we've been seeing consistently, right? Nothing came back from 1234, which is an open port. And that happens with UDP, right? With UDP, if the port's open and I connect to that port and it's not an application that's designed to exchange data back and forth like DNS or something similar like that, I'll actually get nothing back. So the fact that we got nothing back here was because that port was open. Now these two don't get through because we have the firewall in the way with the drop rule. And the firewall is saying, nope, I have a rule saying you can't talk to port 1235 and 1236. We didn't have to let in all upper traffic as possible replies. We're able to say, let our traffic go out, record it in a state table, and those traffic coming in that looks like it might possibly be a reply, go look at the state table and see if you can find a match for that. See if you can match the source IP, destination IP, source port, destination port, and the transport. If you can match those entries against the state table, great. This is a reply. Go ahead and let it through. But if all of that criteria does not match, this is not a reply to a currently active session. Don't let it through. So kind of similar to what we saw with the fin scan, I can no longer tell what ports are open and what ports are closed. So last week when I was talking about firewalling, I was talking about I like using host unreachables. Well, that's specifically like TCP and ICMP. I like to use host unreachables because that kind of fools the scanning tool into thinking, well, maybe that system's offline right now. The problem you run into with UDP, though, is that if the port's open, nothing will come back. If the port's closed, an ICMP host unreachable is what's going to get returned. And that's a different response. So you may actually be better off saying return host unreachables if it's a TCP packet that I don't want to let through. But if it's a UDP packet I don't want to let through, I may actually want to use a drop rule because now open ports and closed ports look exactly the same. You can't tell the difference between the two of them. Cool. So what have we learned? We've learned that no firewall rules, they can get to anything. Static firewall rules, we get a little bit of control, but if a savvy attacker can still punch through and figure out what's going on. If we have a stateful firewall, however, we get far superior traffic control, and we can actually do a much better job of keeping the attackers out. And if we can customize our how we reject this traffic, we can possibly confuse them as well. Like I said, returning host unreachables. Anytime they try and hit a port that's actually something that's getting firewalled, that may shut the remote scanner down and stop it from being able to get in after that. So that's our difference between the different firewalls. Let's see. And again, I'm talking about static firewalls. And a lot of you might be thinking, oh, geez, Chris, that's old technology. That's back when Linux was using IP chains instead of IP tables. What was that, 50 years ago? Nobody uses static firewalls anymore. But the reality is modern day firewalls still rely on that technology. And as I mentioned last week, if a firewall labels itself as being a stateful inspection firewall, all it needs to do to meet that criteria is inspect one application or transport. That's it. And it doesn't even have to do the transport. It can just do one app, right? So they may have implemented stateful inspection to properly handle FTP traffic. And if the only thing it actually inspects is FTP, they can still get away with calling it a stateful inspection firewall. But that doesn't mean you're going to be statefully inspecting anything that is not FTP. If you don't statefully inspect the application, now you fall back on how that transport is handled. And that transport is going to be handled either statically or statefully. If you don't statefully handle the transport, now you fall back on static. And as I said, there are a number of commercial firewalls out there today that still use an awful lot of static packet filtering to implement the firewall rules. Now, the challenge is they don't tell you that, right? None of us have a firewall we're using that when we create a rule, you get a little pop-up that says this rule will be implemented with stateful inspection. This one will be implemented statefully or statically. They don't tell you that. It just kind of happens. And, I also mentioned there are firewalls out on the market still today that even if you create a firewall policy of anywhere going anywhere, drop it, and that is the only rule you create, that one rule and that's it, there's still traffic that can actually pass through those firewalls. So one of the reasons why, and again, we talked about this last week, you want to do this type of testing. You want to do it for yourself, especially if it's a brand you've never worked with before, is to figure out how has the vendor implemented it. Send some SYN scans through to the other side. Set up a packet sniffer. Did they make it through? Yes or no? Okay, now try some FIN packets. Did those make it through? Try some unsolicited ICMP error packets and see if those make it through. That trips up a lot of devices. So again, this is all about understanding what your firewall is doing. Now, if you find out it's, your firewall's got holes in it that you can't fix, or, there's no way to actually block it. Like, let's say you figure out, and I know at least one major vendor does this, they pass DNS traffic, regardless of what your rule base says. If you create a rule that says, hey, anybody going anywhere trying to communicate with DNS, drop it, don't let it through, it's still going to pass it through because they've got a backdoor rule they use to be able to pass that traffic and not let it get logged. Well, how do you know if your firewall vendor is doing that? That's easy. HPing 3. Hey, let's go and create some UDP 53 traffic. Let's see if that actually makes it through the firewall. If so, the policy is not, there's more going on than what shows up in the policy you get to see as a user. You need to start doing some research and doing a little homework on what's actually going on. Now, if a firewall has holes blown open in it, like it's letting through UDP 53, regardless of what you say, does that mean that firewall sucks? Well, maybe a little, but not entirely. In other words, now that you don't control that port with that firewall, you can take steps to mitigate that threat through some other means. Maybe it's a different type of firewall. Maybe on your router, you create a static rule that it will control it that way instead. It's when you don't know it's a problem, you have no options. You're just vulnerable. Once you know the problem is there, you're going to come up with options to mitigate the risk and lower it within your environment. What vendor was that for? Again, asking for a friend. I would rather not say the name of the Israeli vendor that makes this firewall that still looks like a piece of Swiss cheese if you know how to test it properly. And I'll just leave it at that. If you know anything about the industry, you'll know which firewall vendor it is just based on that comment. But awesome. So that's all I've got for this week. So let's see. We talked about. So I threw these slides into the Discord channel. I know we didn't do a lot of slides in this one. I personally like it better when we can do hands-on stuff. But what I did want to do was document everything I said. So like I explained what all those different scripts do, there's a slide in here to give you that. All the different firewall checks we ran and what came back, you get slides for that. So basically everything we just talked about is here. I'm just making sure I didn't actually miss anything. It doesn't look like I did. Which firewall is better? Obviously, we want to statefully inspect as much as we possibly can. That's going to give us the best level of security. Here's an extra slide. Cool. I'll always take extra slides. So next week on Fireside Friday, we're going to start talking about VPN technology. This is one I've been kind of chomping at the bit to get to, because this is one that we all use all the time, right? Like you're using HTTPS, or you're using Quick, or you're using IPsec, and it just kind of works. But what's actually going on? There's no prep necessary for this. Next week is just going to be straight lecture. The week after that, I'm going to start pulling in some labs. So we're going to go through and kind of talk about how to break password hashes and, what is a hash and why is it important that it's unique? And what are some labs around that to show the importance of it being unique? So 2 weeks out, we'll get into doing some labs. But next week, we're just going to get in and just talk about the technology itself. So, but with that said, we are done. Hey, look at this. I'm giving you back a little bit more of your life than you expected to again. So I don't know if anybody else is still in the background, Bill, Shelby, whoever, if you got anything else you want to toss in.
Looks like many of the questions already got answered, but if we've missed something, please go and post it again. We got a few minutes to go over questions and problems that you're running into. I did note, Chris, you're right. Juju had mentioned that it cut off his RDP session into his system when he put the firewall in place. That's absolutely true.
So the firewall was working.
Yes, you just learned that firewall
worked.
Rule
permitting RDP. Therefore, we know the firewall works now. Yay! That's how I learn most things, is by breaking them.
I was doing tech support up near Burlington, Vermont, and you don't need to know much about Vermont, except it's about 2.5, maybe 3-4 hours north to south. I was in the northwest corner, and I was doing tech support on a firewall at a school in the southeast corner, and I typed a command, and all of a sudden my prompt didn't come back. And I knew exactly what happened. I forgot to put in an opening that let my SSH session continue. I had to call and get a janitor at this school on a Friday afternoon stay about 2 hours late as I tootled my butt from northern Vermont to southern Vermont to reboot the stupid thing. Ime, will we be using Ubuntu 2404 LTS? I think Chris tends to use that.
Yes.
Most of what we tend to do is going to be reasonably flexible. Most of what we'll want to do could run on most systems. There is a note that RHEL 9, Red Hat Enterprise 9 in particular, has left IPTables. And so they're actually using, I forget it. I forget the replacement. But
IP
that binary
chairs.
IPS. IP rocking chairs. There we go.
IP rocking chairs, yes.
Yes, probably NF tables. Thank you, Radis. So that might be the only one you might want to skip on this. Most of the other OSs will very happily work with NF tables or IP tables.
Yep. But Red Hat's down to like thinking they're Apple now.
Yeah.
Like, yeah, we'll just go our own way.
Yeah. It's a little frustrating, but yep. William, if you've got questions, go ahead and ask them over on Discord. We'd be happy to help you. Yep.
Yeah. But with that said, thank you, everybody. We take the time to present, but you take the time to show up. And, again, your time has value. We really do appreciate you spending your time with us. It does mean a lot. For those who are interested in the junior sec stuff, I posted slides for that just below this one, along with these slides. So that's just kind of a summary of what Shelby had talked about earlier. And she also mentioned there's a new junior sec channel that we're going to use to go through and organize this and make it as cool as we possibly can. So if you have kids, if you have an interest in helping younger kids to stay safe, would definitely appreciate the help as part of the junior sec project.
Thank you in advance. Absolutely.
Yeah.
Hey, Chris, hope you feel better. Best of luck with your back.
Yes, I'll stop trying to pick up that heavy cat fur.
Yeah, if you just stretched before.
Yes. Yeah. Yeah, I think Eric was right. I got to stretch before I actually try and pick up cat fur now that I'm 105 years old. Yeah.
Hey, thanks so much, everybody. It's great to see you.
All right, everybody. Enjoy your day. Have a great weekend.
Happy Easter, everybody.